Welcome back to the channel, guys. So let's continue our series of making the POTDs. So the today's problem is game of XOR. I see let's see what does the problem say. It says given an array A of size n, the value of an array is denoted by the bitwise XOR of all element it contains. Find the bitwise XOR of the values of all subarrays of A. If you see the example here listed here, you see that it is taking the XOR of all the subarrays XOR. Like the subarrays possible for A are 1, 1, 2, 2, 3, 1, 2, 3, 2, 3. Okay, so it took subarrays of all the subarrays. Oh, it took XOR of all the subarrays. Like XOR of 1 is 1, XOR of 1 and 2 is 3, XOR of 2 and 3 is 1, XOR of 1, comma 2, comma 3 is 0, and XOR of 2 is 2, XOR of 3 is 3. Now, with the results we got here, we are taking XOR of all the results like 1, XOR 3, XOR 1, XOR 0, XOR 2, XOR 3, which would be equals to 2. And we have to report that 2 is the final answer. So let's see what is it is doing. For example, the subarray given to us was 1, 2, 3. It is the input array given to us. Subarrays can be taken as, first I'm writing the subarrays of all the length 1. So for length 1, subarrays possible are 1, 2, 3. For length 2, it would be 1, 2, 2, 3. And for 3, it would be 1, 2, and 3. Okay. I think you know about the difference between subarray and subsequence. If not, I'm telling you, subarray is a continuous block. Okay. And subsequence, that you can choose fragments. Also, subarray is a part of subsequence. Like subarray is a subset. That would be a better term. Subsequence. Okay. Subsequence. Like subarray, all the subarrays are subsequences, but all the subsequence may not be subarrays. Alright. Let's move on. So it says we have to take the XOR of 1, then XOR of 2, then XOR of 3, then XOR of 1, 2, then XOR of 2, 3, then XOR of 1, 2, 3, and take the XOR of all these results to get to the final answer. So how it would it be worked? So the first most brute force approach is take all the subarrays, calculate the XOR, and then calculate the XOR of XORs. So what would your time complexity of it? We all know to take all the subarrays, we would run a nested loop, and it would give a time complexity of n square. And then for all these, it will be O of n, O of n. So total time complexity would be O of n square. I'm telling you only the brute, simple optimized approach because that's also very simple. You just need to keep in mind some of the properties. Optimized approach. Pay attention, guys. So to solve this problem, you should be familiar with the XOR properties. Okay, I'm listing the properties you need to know. X XOR X is always equals to 0. Element XOR with itself is equals to 0. First property. Okay. Now second property is an element XOR with 0 is always equals to the element itself. Okay. And third property, X XOR Y XOR Z is also equals to X XOR Z XOR Y is also equals to Y XOR X XOR Z. Like the order in which we solve XOR does not depend. XOR's XOR answer is independent of the order we execute the statements. All right. So you are now well versed with the properties to solve the following question. Okay. Now, for example, the array given to us is 1, 2, 3, 4, 5. Okay. Now, I have observed that x or x is 0. So I can think if somehow I get the number of ones, like what we are doing right now is subarrays, XOR is 1, 2, 3, 1, 2, 2, 3, 3, 4, 4, 5, so on up till 1, 2, 3, 4, 5. What we are doing, what we are producing is the XOR of all the elements 1, XOR 2, XOR 3, XOR 1, XOR 2. Now, see the XOR is coming in the brackets also. Okay, XOR 2, 3, XOR 3, 4, XOR 4, 5. Okay, 4 or 5 का भी XOR होगा. And then at last we are XORing it with 1 XOR 2, XOR 3, XOR 3, XOR 3, XOR 4, XOR 5. Okay. Now, according to the property 3 mentioned here, this can be equated as 1 XOR 1 XOR up till this would be equals to number of time 1 appears. In bracket XOR 2 XOR 2, number of time 2 appears. Up till XOR 5 XOR 5 XOR up 5 appears. Am I correct? Okay, I think you are understanding what my point is. Now I'm going to say that if 1 XOR 1 is 0, then 1 XOR 1 XOR 1 would be 0 XOR 1, and we know XOR of 0 with anything is 0, is one number itself 1. Okay, so can it reduce, like if a number x appears even number of time, then its XOR would be 0 because of the pairing, like 2 times, like x appears 2 times, so x XOR x is 0. If it appears 4 times, x XOR x is 0, and the other 2x XOR of 2x gives us 0, and 0 XOR 0 is 0 as always. Okay, so we are able to understand that if it appears even number of time, it would be 0. But what if it appears odd number of time? For example, 3. So it would x XOR x XOR x. This can be reduced to 0 XOR x, and this is equals to x. So what we have to do, if we have even appearances of a number, we do not need to do anything. And but for the odd appearances, we just XOR that number to our final answer. Okay. So the only problem left is calculating the number of times an element number of times an element appears in all the subarrays. This is our main problem left. Okay, so how do we solve it? Now pay attention, this is the most crucial part of the question. For example, the array is 1, 2, 3, 4, 5. Let's count for 1. We see 1 appears as single 1 in 1 2, in 1 2 3, in 1 2 3 4 5, in 1 2 3 4, and in 1 2 3 4 5. So the total number of time 1 appears is 5. If you can count 1 2 3 4 5. Also you can see the length here is 5. Now number of times 2 appear, it is equals to 1 1 2, it is equals to 1 if it is coming on its own, 2 times if it coming in pairwise, and for 3 times it is coming like 1 2 3, and then 2 3 4, only 2 times. So 2 times if it coming thrice in the pair of in the group of 3. For the group of 4 it is coming like 1 2 3 4 and 2 3 4 5, 2 times again. For the time in the 5, in the group of 5 it is coming only one time, because only one subarray is present in the length of 5 of size 5, like this. Now this can be represented as, supposing a length has 5, which can be equal to n, it can be quoted as 2n minus 1 star 2. Pay attention here. Like, if I were to do plus 1 here, it would be equal to 2 times 5, or 5 times 2 minus 1 star 2. Okay, because I have to do minus 1 also. Now if I am doing plus 1, okay, it is equals to 2n minus 1 2. Okay, now count the occurrences of 3. I'm rubbing it for more clarity. For the number of times 3. Now 3 comes, for the length of 1 it will come only one time. Okay, in the length of 2 it will come like 1 2 2 3 3 4. It is coming in the part of 2 3 and 3 4. Oh, right, so 2 times. In the part of 3, as a part of 3, let me erase. As a part of group of 3, it is coming 1 2 3 1 2 3 2 3 4 3 4 5, 3 times. As a part of 4, it is coming 1 2 3 4 2 3 4 5 3 4 5, only 3 times. As a part of 5, it is coming, as a part of 4, sorry, as a part of 4 it is coming only 2 times. There is been confusion while marking here. As a part of 4 it is coming only 1 2 3 4 and 2 3 4 5. No other subarray of length 4 is possible, so it is coming 2 times here. And for the length of 5 it is coming only one time. So if you observe, it is 3n minus 1 plus 2 star 2. How can I derive that at this? I'm saying that add plus 2 here, plus 1 here, plus 2 here, plus 1 here. So we have to do 3 plus 3 plus 3 plus 3 plus 3. Now because I added them, I have to subtract them too. So I have to minus 1 minus 2 minus 1 minus 2, which is equal to minus 1 plus 2 star 2. Okay, so if you observe, I have got this pattern 3n minus 1 star 2. Now I can go on further and reduce this type of array, but if I see the number of time 1 will appear is equal to number of time 5 will appear, how can I reduce that? You can check from the values itself. Number of time 4 appears, number of time 5 appears. I'm just marking the number of time 4 appears now. Number of time 4 appears is, in the length of 1 it will be 1, in the length of 2 it would be 3 4 and 4 5, so 2. In the length of 3 it would be equals to 2 3 4 3 4 5, it is also equal to 2. In the length of 4, 4 it would be equals to 1 2 3 4 and 2 3 4 5, 2. In the length of 5 it is equals to 1, so it is also equals to uh, 1 plus 2 plus 2 plus 2. Okay, now number of times 5 appears is, in the length of 1 1, in the length of 2 only 1, 4 plus 5, in the length of 3 1 plus, oh, 3 3 4 5 1, in the length of 4 2 3 4 5 1, in the length of 5 1 2 3 4 5 1, it is equals to 5. If you observe, number of time 1 appears is equal to number of time 5 appears. Number of time 2 appears is actually similar to number of times 4 appears. 1 plus triple 2 plus 1, 1 plus triple 2 plus 1. And number of times 3 appears does not match with anyone. So I can see that if suppose A, B, C, D, E, F, G, H, I is my array, this array and this array will appear same number of time, this and this will appear same number of time, this and this will appear same number of time, this and this alone will appear. That is the different concern. If it is an even number of if n is an even number, then e also should have its companion, but for odd it will be left out alone. So what I am observing, that if I somehow use a two pointer technique, like A, B, C, D, E, F, G. Okay, I am placing my I here, my J here, and I'm doing like A comes n times. Okay, G comes n times. Okay, B comes 2n minus 1 into 2 times. This also comes 2n minus 1 into 2 times. Now this comes 3n minus 1 plus 2 into 2 times. So this will also come the same number of times. And D comes 4n minus 1 plus 2 plus 3 into 2 times. I am able to observe a pattern, and I have reduced the pattern that for the ith element it would be equals to I plus 1 into n minus 1 plus 2 up till n up till I star 2 number of appearances of ith element, and j is just related to the number of appearances to ith element. Okay, so I and j both are sorted. So I have to solve this problem. So let's look at the code, and then I will explain you how the code is working. All right, so coming to the code, I am first declaring a variable int answer equal to 0, which will be holding my final answer. All right, int answer equals to 0. Now, as you were observing that we were subtracting 1, then 1 plus 2, then 1 plus, so I'm storing that in another variable named as int sub is equals to 0, because in the starting we were subtracting 0 from the first element. And now, and if you observe that we were adding 1, then 2, then 3 to the sub. So to add, I am keeping it as value equals to 1, the number of the number which has to be added to the sub. All right, now the index I am working with is currently 0, and it will work until index is less than n. Okay, so if you observe, we reduced here number of occurrences is I plus 1 n minus 1 plus 2 plus 2 up till I into 2. Okay, instead of n I am working I forgot we were working with the two pointer approach, so we have to got two operators. I run a loop up till up until I is less than equals to j. All right, I calculate the possibility, the number of appearances, int number equals to I plus 1 star n minus number which has to be subtracted star 2. I see if number is divisible by 2, we do not have to do anything. If number is divisible by 2, we have to do not anything. But if it is returning an, if it is an odd number, we have to do something. So to not account number again, like in the cases of the odd array, I and j will come on the 1 point. But then we do not have to take XOR two times. We have to take the XOR only one time. So what I'm doing, I'm saying that if I is equals to j, take XOR of the given number only one time. That is a of I. Else we have to take the XOR of I as well, also j as well. I hope I am clear here. Okay. After that, what we have to do? We have to update the sub equals to sub plus. Oh, I do not have to initial analytic sub equals to sub plus val, and then I have to increment val to increase the sub by the next number in that consecutive. After that, I will increase my pointer and decrease the jth pointer, and then at last I will return the answer. Let's see if it works. I hope I've not committed any silly mistake while solving the problem. So it is working for the example input. Let's see if it is working for the submit button also. Yeah, it is. Congratulations, we have done it for 3 days regularly. If you are following me, so let me explain you the code. This stores a final answer. All right. After that, this value is the number we have to subtract. Like we were subtracting 1 plus 2 into 2, 1 plus 2 plus 3 into 2, if you remember. Okay. This is a number I have used. Like if we are standing on 1 plus 2 and I have to add 3 now. So I'm storing the 3 here in the value operator. Okay. These are the pointers I equal to 0 and j is set to the last element of the array. I'm running the loop and up until I is less than equals to j, that they will coincide at the middle part of the array. I'm calculating the number of appearances the element will occur in the total number of sub arrays. If it is an odd number, then we have two possibilities, that I and j are pointing to the same element. If they're pointing to the same element, we have to take the XOR of only of the element one time. Na? We have not to take the element two times. So we are taking only one time, I of a of I. But if they are different, we have to take the element I as well as j. I think I'm clear here. After that, after the if statement has been executed, we have to increment the sub for the another cycle, and we have to increment the val also for another cycle. And for the next cycle, we have to increment and decrement the operator likewise, so as to shrinken the array, shrinken the part we are concentrating on, and reach our answer finally. At last, we just return the answer. I hope that it was the clear one. Thank you for watching the video. Please don't forget to subscribe.